Hi. So, per our last video where we tried to get automation going and we failed, it was a really good learning experience because basically what happened was we tried to get auto approvals for really tiny kind of trivial projects of our own, just play around projects for our own to auto merge dependencies so that when we came back to those projects we wouldn't have to worry about that toil or it wouldn't be a recurring thing. But we also discussed about the importance of the moment that some risk starts to enter in, we don't want to have to think about that at all, right? Like we don't want to have to think about the possibility that something got merged in that shouldn't have been, right? That has a security vulnerability or causes the application to crash constantly. One thing in particular that I wanted to go over today was to talk at great lengths about caching. So this is going to discuss a little bit about performance. One thing that becomes a point of emphasis or even a point of friction for teams that work with CIs is when you start to build stuff on a pipeline for a project, that pipeline will begin to get slower and slower and slower. The more and more dependencies that you get, the longer the build is going to take. You're basically pulling in code that somebody else has written and saying to the compiler or the build script or whatever it is, please go right ahead and build all of this stuff. So the build time will get incrementally longer every new dependency that you add. It might get longer with extra steps that people want to add in. So maybe they have a step for deployment and releases and tagging artifacts and, you know, maybe publishing out to a test framework, right? So like there are snapshot testing frameworks. Percy is one. You know, you might have Cypress and stuff. These things could be their own tests or their own steps, excuse me. And part of this whole series is to really get down to brass tacks of like a build is kind of a general purpose pipelined thing for executing arbitrary tasks. Okay? That, just to say that again, a CI is a general framework for automating tasks. Okay? The gist behind having a CI is that a CI gives us this flexibility to be able to say, well, in this step, run these things. And scripts are incredibly useful for that, right? The moment that your YAML specification starts to get longer and longer and longer is the moment, and you start going, oh, this is getting a bit hairy, right? At 4 or 5 lines or something, you should then say, well, no, I'm not going to do that. I'm going to move all that stuff into a script. And in fact, one day we will do that. We will probably have several lines that are being carried out, and we'll start a bin or a scripts directory, and we'll say, this is where this publish step is, this test step is, etc. That way it gives you a lot of flexibility. The one mistake I see a lot of people do is they start using make files, and make is not a task runner, right? Scripts are kind of these generic things that run programs, right? And they kind of stitch programs together to do behavior and check exit codes and make sure that things are running properly. And they're archaic in a certain way, but they're dependable and they're very portable, okay? So that's why we tend to reach for them. And some people who really hate them, right, they might try to have task runners like written in JavaScript, or they might have task runners written in, you know, whatever language of choice, Python, etc. That way they can largely have a team of people who are not experienced in shell write tasks bit by bit. But it's my opinion that you really ought to just use shell. Okay, just use shell and be done with it. And there might be other task runners or whatever. Just confer on one thing. Don't have too many different things. Okay? And the problem with having things like Python and JavaScript and etc. is that people start introducing dependencies for those task runners to run when you really don't need that. You'd rather have just a bunch of little other programs that are getting invoked in some sort of recipe list manner, one after the other. You've just sort of sequestered them into this artifact called test or publish or whatever. So that's enough ranting about scripts. as every step that is coming into this pipeline or this build increases, as dependencies increase, things start to slow down. The pipeline is eventually going to take longer and longer for every build. And one of the simplest ways to speed it up, besides getting actual speed ups on like, are you running with particular flags, or are you, reducing steps from doing unnecessary work, general performance stuff. One common performance thing that is also general is caching. Now, GitHub Actions has a cache action. This I quite like because it looks very similar to other platforms' cache mechanism. Basically, you have this thing that says like, hey, here's how I calculate this key for this cache, and here's how I restore that key. I think that's what restore cache is. An ordered list of keys to use for restoring the cache if no cache hit occurred for a key. Actually, that's a really cool thing, and we will talk about that. A cache is a collection, a build cache, sorry, is a collection of all the dependencies, including your application that's been built. That is tarbled or whatever. It's compressed somehow, so as to save space, and then it's stored someplace remotely. Okay, it builds on that particular Docker image or container image or whatever you want to use. It might build on a specific machine. If the machines are cross-compatible enough, you might be able to do something like what Bazel does or others do, which is like, there's SC cache, which is a wrapper around C cache. You have developers who have workstations, and you have the CI. And if the machines are similar enough, if the architecture is similar enough or the same, then developers can also be pushing and pulling these caches and gaining the speed up around that. And when they push and pull as they're developing, that will also make artifacts, caches available to CI, and CI can use that. Okay, so you might have a mechanism, okay, where let's just imagine that we wrote a script. If we were to recreate this caching step as a script, what we would be doing is basically, some key value store where we can put binary data. Let's just say like Amazon S3 or DigitalOcean Spaces or whatever, right? You have credentials someplace, whether that's on the build bot, because you would need credentials to access this special cache, storage. And then you would build everything. You'd have specific files or specific directories or whatever. And then what is commonly done is you take a hash, right, of the specific like lock file or whatever it is that embodies what got installed, specific versions that got installed, etc. That's generally a lock file. And you'll see here that they have hash files, package lock.json. Now, it doesn't really matter what hash you use. You just want to use something that's deterministic and that has relatively good sound analysis of things changing, right? And if a log file really has changed, like 1 byte has changed or whatever, you're not so worried about it. Generally, a cryptographic hash like SHA-256 or whatever will do just fine. Okay, some people even just use MD5 or whatever because it's not really a sensitive thing. You just want some kind of fingerprint that says this is what this specific hash points to, right? And you don't want too many collisions or anything. You can do that with a command called SHA-SUM in most distributions. And SHA-SUM has many different algorithms. So you see here, one is the default. So this is a SHA-1. And then you could say SHA-SUM-A 256, 512, whatever. And then let's go to actions. So let's go to there and go actually to where we want. We can say SHA-SUM-A, what is it? Our cargo dot lock. Hold on. Oh, right. 256 cargo dot lock. Yep. And so this is the SHA. That's like our fingerprint of what's in this file. And if we change one thing in that file, let's just go and change like that, right? Now, when we do this, you see these two hashes don't match. The fingerprints are not the same, okay? And that's really handy because then that means we can then, you tarball the whatever output is, like the target directory or something, which is the output directory for Rust projects. And to be more precise, you probably tar, there's generally like a debug one, and then if you've done a release build, which I may not have, yeah, that doesn't exist. But if you did cargo build release, you'd have a release build. And then maybe all you care about is just like caching specifically the debug build or specifically the release build, right? And you might add that to the key. So after you've compressed this thing with a specific file name, you would then stash it someplace, so like AWS S3, copy, maybe it looks like this, right? What is that? Hold on. Here we go. Let's see if I can get, copy paste to work in Vim. That's not gonna work. This has plagued me for the last few videos, hasn't it? There you go. That's what it is. So then we might say like debug and then tar zip. Okay? And we copy that up to like S3 my like CI bucket, whatever, and maybe with the same file name. And that's it. And when you have some canonical way of constructing that string, right? Which if we go back up here, we'll see. So it's like, what operating system did this run on? What specific, tooling or platform or language or whatever is related here. And what are we hashing, right? So this is the hash. And then you might have things like what we had below with the debug or something. So this is the canonical way that it's going to construct this key. And what it's going to do is it's going to go off, it's going to ask for that key, and it's going to pull it down if it exists. What happens if the key doesn't exist? Now, most caching systems, right, for CIs, just say, well, whatever, I don't care. I'll just get rid of it and build from scratch. I've got nothing, so I have no cache to work with. Now, I propose something else. I think that for general purpose, projects and things, if you want to get around not having a cache, just name your caches something really generic and use one cache for everything. Okay, so maybe you say tar, target, debug, and then you might call it, I can't remember the actual flags here, but you might call it something like, actions cache. Bam. Now you always have a cache. You're carrying it along. And this is favoring sort of a property called locality. There are two types of locality, and I will go on a quick little rant about locality. But there is temporal locality and spatial locality. This is a little bit more like temporal locality. So we have this one cache, right? And the way that we tend to do PRs is somebody's going to raise a PR. The way that we tend to do changes in a code base is that somebody's going to raise a PR. They're going to make some changes on that. They're going to approve it. They're going to merge the thing in. And it's very, very likely that whatever dependency changes are there are not going to be really, really drastic, okay? They're not going to have whole operating system changes or, whatever. And in fact, the whole purpose of having this triplet here or even having the operating system here, is that if there's ever a build on a different machine, we'll at least pull dependencies that work on the machine that we're on right now. Now, with this particular approach, what we are doing is we are saying, I've changed the dependency. I've only changed one dependency or two dependencies or three, but there's still maybe 14, 20, whatever, however many dependencies left that I actually can keep in the cache, and my build tooling, say Cargo or Go or whatever, can take advantage of that. And the rest of whatever's there, the old versions, they'll just get ignored, right? Because our actual specification file doesn't mention them, right? So the build tooling would just say, I'm just gonna pretend that those don't exist, right? It's a bit bloaty, and occasionally, if things get corrupted or there's problems building or whatever, you might have to blow it away. So there's a little bit of manual poking involved with that, whereas this is always creating new ones. Their option is to have this extra key, which is like our generic key, right? So in this case, it's just the runner operating system and node with a dash and no hash related. That's totally fine. Okay? So, how are we going to do this? Right? We're going to speed up this cache. And we're going to do it by, what is it again? Yep. And we'll also open the weekly one that we had. Rest weekly, there we go. Yes, so we are going to take this step, okay? And this step is going to try to, it looks like, find a cache. Now, it's not clear if we need to have a step in here, like a little individual step that pushes the cache up. Because you normally would, right? You need a step before that pulls the cache down, and you need a step afterwards that pulls it up. Okay? Now this path is here, and what possibly is happening is that this gets installed, and then this sits here, and it watches that thing, and at the end of the workflow, probably there's a hook that says, this is my guess, that there's a bit at the end that pushes it up. So there is this save function. Action utils, contracts, constants, VS Code, workflows, tests, prettier, get ignore, examples. So is there an output? Let's see, what is it running as its entry point? Dist restore. So where's dist? Dist is not VCS. Right? It's not put in VC, so there's got to be. There's this workflow thing. There's our matrix thing we talked about last video. Builds on Ubuntu latest, Windows latest, and Mac OS latest. And yeah, so it runs this CI stuff, run format check, and then run test. And one of those probably produces, whoops, my bad. One of those probably produces what we were expecting. So build, test, format check. This just runs TSC. So yeah, we'll probably get some kind of output. I have not seen a CI yet. So this ensures that it's always doing a clean install. npm CI. Huh. All right. Well, really what I'm after here is trying to figure out if I need to do this. But I think what happens is tests, VS Code. I really just want to know where the entry point to this is. Here we go. Save cache. Let's go find save cache. That's not mentioned here. Contracts, restore, save, constants, utils, action utils, save cache, set cache state, etc. Curious, man. Yeah, there's no Docker file or anything. Really, really wild. It's actually producing, there's no releases. I think I'm just missing something. But sets up node, runs npm CI, runs prettier, runs build and test. Test. Don't tell me there's something horrible like the tests actually run dist. What's this actions thing? It might actually build on your workflow once and set itself up. Yeah, wild. I think it might. Let's just see. Let's just find out. Yeah, best way to learn anything is just to give it a go. We'll just code this in. So we're gonna have to tweak this a little bit. There's some ecosystem examples that might have Rust. It doesn't really matter. We can largely just figure out how to do it ourselves. We'll leave that up for debugging though if we need to. There is this tidbit here that's kind of important to note, which is that it says that caches are limited to 200 megabytes and a repository can have 2 gigabytes of caches, right? So each individual cache cannot exceed 200 megabytes and the whole repository can't exceed 2 gigabytes. Once the 2 gigabyte limit is reached, all the caches will be evicted based on when the cache was last accessed. And that's totally fine. I think that's, you want something like an LRU because after a particular point in time, you don't care about old caches. And this is something of like, that you would want to set up as, if you were using S3, you'd want to set up a lifecycle policy that evicts older, artifacts inside of this particular bucket, right, or prefix or whatever. If you're using DigitalOcean Spaces, so you might have a script that occasionally goes in there and cleans things up. It just depends on what's available to you, right? What we are going to do is really simple because I'm going to copy this generic one, except it has this cache hit thing in the cache steps. Okay, and what this says is that if we have a cache hit key, we can actually skip certain things like building, right? So if there's an explicit install step, we can skip that. So this is actually pretty cool. I think this is pretty well designed, personally. So that was test. This is build. Here's what I'm going to do. I'm going to say build and test, right? And whatever we fit out here, sorry, let's actually shut this down here. Cache preview, ID cache, path to dependencies. So that's target debug, remember? Now, runner OS is fine, hash files, so we just want to say cargo.lock. Actions rs cargo v1. So yeah, that's it. And then down here for the build, after the checkout, we want to say runner OS, this is target release. Okay, and that's it. So that we don't have to wait for two of them, let's topic flow topic. Yeah, that ought to do it. So the thing in particular to note is that again, it's really important to understand that they're probably doing some specialty thing here where after mentioning this, at the very end of this build step, it will probably run a save cache bit. And reason why it's doing that, so we've got test here and build here, and they're broken. So let's go find out why. The template is not valid. Interesting. The search pattern cargo lock doesn't match a file under, so they did have something interesting, which was that they had ****. Bob for log file. Okay. Now, if we go back to like the definition of a CI, right? It's just this generic framework for running or automating tasks. In this particular case, where we don't have this specialty action of things saving afterwards, although a lot of SaaS providers like Circle CI, I think, does it this way, and Travis. If you are using those, then fantastic. It'll just work out of the box for you, right? But sometimes, like, I think like GoCD and a couple of other, like Jenkins might do this as like a particular cache plugin. Other things like BuildKite and stuff, you'll have to specify this step yourself, where you check for the cache, pull down the cache, and you bring it back up. I want to talk for a second about that because this actually passed. Cool. Cache not found. Says here, there we go. And look, if you don't have a CI that offers this to you, or you're building something from scratch or whatever, you would really just sort of run these types of commands. And let's look at this tar command, right? It's saying tar compress with gunzip. This file is what I want it to be called. I want it to be called this hash thingy, right? Which looks kind of like a UUID. Yeah, so this is a temporary directory with a UUID, and the file name is cache.targunzip. Okay? And then it's saying home, runner, work actions, actions, target, debug, dot. And so this is specifically what I want this to be compressed, right? And I want all the other stuff too. I think dot is for the context of the sourcing or something. Any case, doesn't matter. If this cache already exists with this key, interesting, then it won't upload. So let's go look here. Cache saved successfully. So for some reason on this test one, right? Let's go back down. Just to sort of sanity check our changes. Yeah, so target release and target debug. Okay. Now, it's a little funny that this cache warning is here, because down here, right, it's saying, I actually, yes, saved off that cache for you. it MD5 sums this whole directory. That's interesting. Or no, the specific cache thing. And that's the result, and then that's the checksum. So saved successfully. Cool. All right. Now what you'll find, to get this demonstrated for a second. Oh, well, let me finish my one train of thought. Okay. You would just run this tar command yourself in a script. You would have the thing that you would upload to, and you would just run that, right? Whether you build a binary that automates this, or you just have some script that does it for you, it's not that complicated, right? You're just kind of stringing together some functionality to get this artifact, as we refer to them, right? This cache, put someplace so that you can eventually find it later using some canonical means. What I'm going to do is I'm going to merge this, and after it's merged, we are going to go back to master, cache scheduled builds. Okay, go back here. Now, all of this is going to get copied over. Right, and if you remember, we had some problems with getting the scheduled thing to run in tandem with the push. So there's a little bit of oddness there that I might have to look into, but cache scheduled builds as well. I just cache scheduled builds. Whoops. Let's raise that one. And caching stuff, really the core idea of putting stuff onto disk, right, that's already been finished, it's expensive work that's been finished. You're just giving some mechanism for finding it later, right? So this has been merged. You can close all those. Don't need that anymore. Don't need these examples. And now you'll look and you'll see this preview step, right? Hit was true, cache was restored. Here's the cache checksum, bam. Now we've got this cargo file, and because, right, this cache hit occurred earlier, it's got nothing to do. It has nothing to save, right? Now it's possible that after this action runs, it might look at the cache and say, oh, well, you know what, this has updated, right? And the hash of this result might be a bit different. You would hope that it does that. And now that we've added this to the scheduled builds, that's there as well. So we can kind of go, the scheduled builds, remember, we're supposed to be built on, I think is weekly that we set it up for. So let's go, here we are. So we've got dependabot ones, and we want to find ones that were scheduled builds, right? So yeah, 7 days ago, took 40 seconds, topic dep, CI, that was us setting things up, and stuff setting up the scheduled builds, and we kind of just want to check to see the scheduled builds are running. Alright, schedule weekly builds. That got in. So, what's this push? Yeah. I'm not convinced the scheduled builds are working quite yet, but maybe in the next video we can start to plumb and see, is it actually doing what we expect it to do? Hopefully this was a really good example of what you can do to speed up a pipeline, and caching is a really big aspect of that. the general rule of thumb for pipeline speed is about 10 minutes, right? Like a good pipeline speed is about 5. If you have a really massive mono repo, which is where you put all your code in one repository, if that build is taking too long and you are also kind of dealing with a lot of complexity or whatever, and it seems less complex to break it out into individual repositories, that's one approach, and then each individual pipeline can run in parallel. Running as many steps in parallel as you can, so as you saw with our workflows, right? All of these CI ones, they basically, they ran in parallel. So test and build ran in parallel rather than running sequentially. And so if you can pull things out of individual sequential steps into parallel steps where there's no dependencies between them, then by all means, break those things up into individual steps, because that will speed things up, sometimes drastically. Caching, though, is usually what we want in place regardless, because that can just take up so much time compiling other people's code. And you don't want to have to pay that penalty, especially if you're paying money for build minutes, or you find build minutes to be very precious for your project. So there you have it. That's kind of an intro into caching for build pipelines. And I'm not sure what we'll talk about next time, but I'll have a think and hope to see you again. Bye.